In this review, we're going to look at a question involving two weights being suspended by ropes. Okay? So my question I'm going to look at is going to look like this. I'm going to have two weights, one weight here of 100 newtons, suspended by ropes. Okay? And we want to figure out the tension in these ropes. And we're going to put this up here. Okay? And we're going to be given just this angle here. Okay? And this is connected to a ceiling. Okay? So we have a 40-degree angle. Now this looks complicated. It looks like we're missing way too much to figure out maybe what is going to be this tension 3. What is the tension in rope 3? It looks like we're missing way too much. But essentially, we are not at all. We're going to break this down into little mini systems. So first, let's look at this system here. This first half there. If I'm looking at this system, I have 100 newtons. This rope here is holding up this system. This rope here is holding up this system. This tension here is keeping the balance between them so they're not moving left and right. Okay? So, let's look at this system here. I'm going to first break this down to its x and y components. Alright, this must be 40 degrees. Now, I know my y here pulling up must be 100. Since if I have 100 newtons pulling down, I must have 100 newtons pulling up. Now, given that, that makes to find my x value so easy. Alright? So my x value here is so easy, and this force, this tension, this rope, I must balance out this x value. So in other words, my tension in my x is equal to, we're going to have 100 newtons cosine 40. And that's going to end up giving me a total of my tension, my x, is going to be 76.6 newtons. Alright? Now, if this is 76.6 newtons, this rope must have a tension of 76.6 newtons. Otherwise, what's going to end up happening is my forces are going to be moving left and right, left and right, left and right. Okay? So we know now that this here is 76.6 newtons. Well, if this is 76.6 newtons and it's pulling this mass this way, now that's telling me over here this x must be 76.6 newtons as well in order for everything to balance, right? Because all my x's here must balance. This must be in system, so this x must equal to this x. This must be in equilibrium, so this must equal to this. Now that I know that, I'm working backwards. I know that this must be 150 newtons. Now I could figure out what my tension in rope 3 is. It's simple. I could just use Pythagorean theorem. So I know r squared is equal to x squared plus y squared. In this case, my r is my T3, my tension in rope 3 squared is equal to T3x squared plus T3y squared, the tension in the y for that one. Okay? So we're going to end up going here. We just want to figure out what my tension is altogether in rope 3. And I know what my tension in the x is for rope 3. That is 76.6. And we want to square that. Okay? And I know what my tension in the y is. That's 150 newtons. Okay? Now I'm just going to calculate that in my calculator, and I'm going to end up getting 168.4 newtons. So I know this is equal to 168.4 newtons. Alright? So, that part's done. But this is not all of tension of 3. I need to figure out what angle it is. Because remember, this is a tension and a force. It's a vector. I have to figure out what is the angle. So to figure out this, I'm going to use Autosir-Cox or TIX. I'm going to use TIX. I could use either one because I know the resultant, I know x, and I know y. But I'm going to use TIX here. Okay? So I'm going to have tan theta is equal to, move this all up, my y, which is 150 newtons, divided by my x, which is 76.6. All right? We continue that. I'm going to end up getting theta is equal to the inverse of tan, which is going to give me a total of 63 degrees. So in other words, I end up getting 63 degrees. Okay, so let's recap what's happening here. All right? We broke this down to two systems. I have this system, and I have this system. I have my left and my right system. We have two masses. This one is controlling the y value for this system. Okay, so I automatically know the y value. If I know the angle, then I can start plugging in and using that to calculate my x. Now remember, this must be at equilibrium, so these must be balanced. So the tension in this rope must be what's holding this x in place. So this x must equal to that, because my sum of my forces in the x must equal to 0. Okay? My sum of the forces of the y must equal to 0. That's how I know this y is equal to this y. This x is equal to this x. Now that I know this x, well, if this is pulling this way, this must be pulling that way, and this is pulling that way. So this tension in this rope is pulling this force here this way. So then this tension must equal this, because once again, my sum of f of x must be equal to 0. So this must equal to this. This is a negative, this is a positive. Just like this one here. This is a negative, this is a positive. This y value must be controlling this y value. So this force must equal to this force. Now that we know all of this stuff, it's easy to find what is my resultant, or the tension actually in the rope. I know my x and my y, so then I could find my resultant. And then I could also find my angle here, which was 63, which means my angle from the wall is 63 degrees. And that is how we solve this question.